Whether you are making a video game, a photo booth, or a karaoke machine, any program you write must store and manipulate data. Data can be a player's score, the price of a stock, or the position of a joystick in a player's hand. Variables are named memory locations. They're the temporary containers where the microprocessor stores data. Variables come in many different sizes to store different types of data. And you can give them a name, any name. But you must declare them before you can use them. When we declare a variable, we are giving it a name. We're also assigned a type or a class, which is like a blueprint that the compiler can use to decide how much space it needs and how to lay out the variable in its memory. Declaring a variable is very easy. To declare a variable, we simply tell the compiler the variable's class, followed by its name. Here the class or the type is a Boolean, which is a true-false variable, and the name is Fred. Bool Fred simply tells it the type and the name. Here we'll create an integer, call it Sally. An integer can hold any whole number. Here we create a float or a floating point number, which is a number that can have a decimal point or a fraction in it. Call it Ralph. Here's a short program where we start by creating an integer called count and set it to 1. We then create a float called total and set it to 0. Count's been initialized to 1. Total is initialized to 0. Once we've defined these variables, we can use them in our code. Here we simply add 1 to count. Now we tell the microprocessor to add 25.6 to total. Once there is no more code to access our variable, or as we say, they have gone out of scope, the memory will be freed for other data. In addition to integers, booleans, and floats, C# supports many other types of variable. Long and short integer, unsigned integer, double precision floating point value, decimal value, characters which can hold individual letters or symbols, strings which are long lists of characters, or indeed lists of any of the above. There are also compound objects or classes that can hold a rich variety of data. Or you can create your own unique class containing a variety of elements. Here we'll take a look at one of Unity's classes, a vector3. We'll call it Vicky. As you can see, Vicky has an X and Y and Z value. All but the simplest data types must be allocated with the new command. Without the new command, simply declaring a rigid body, the rigid body is null. It's not actually connected to any memory. Adding the phrase new rigid body, we are instructing the compiler to actually attach and allocate memory to that value. Now we can access its elements. Here we use the dot operator to set the rigid body's mass equal to 10. Then we look at the rigid body's velocity and store it into a new vector3 called v. Notice how I've replaced the vector3 with the more generic keyword var, asking the compiler to infer from its value what type of variable might best hold it. My name is Harry Every. I hope you've enjoyed this micropattern tutorial, and I wish you the very best on your continued adventures developing cyberspace.